In this lesson, we're going to use all the factoring skills that we've learned in the previous lessons in order to solve polynomial equations. Okay, so the first step in solving a polynomial equation is to write the equation in standard form. That means we're going to have it set equal to 0. Okay, next we're going to factor our polynomial expression. So we went through the last 3 lessons factoring parts 1, 2, and 3, learning all the different strategies for factoring. So first factoring out a greatest common factor if there is one, then looking at the number of terms that are left and choosing a method based on the number of terms. Lastly, once we have our polynomial expression factored, we're going to use the zero product rule. So that's why it's important in step 1 to set our polynomial equal to 0. The zero product rule says that if I have a product, and it doesn't have to be 2 factors, it could be 3, 4, 5, as many factors as possible. If it's set equal to 0, think about what that means. Think about multiplication with 0. Either that first value is equal to 0, or the second value is equal to 0, or both of them are equal to 0. So the zero product rule is going to give us a way to find the value of the variable by setting each of our factors equal to 0 and then solving those resulting mini equations. So in this first example, we have x squared minus 10x is equal to negative 24. So the first thing we need to do is write this in standard form by adding 24 to both sides. So I have x squared minus 10x plus 24 is equal to 0. Since this is a quadratic trinomial with a leading coefficient of 1, I'm going to use the AC method to factor it. So I'm looking for 2 numbers that multiply to 24 and add to a negative 10. So those 2 values are a negative 4 and a negative 6. Okay, now that my polynomial is factored, I'm going to apply the zero product rule. So I'm going to set each of my factors. So I have 2 factors here. I have x minus 4 and I have x minus 6. And I'm going to set them equal to 0. And solve each of these resulting equations. So x is equal to 4 and x is equal to 6. So we have 2 solutions to this polynomial. Okay, in the next example, I have 5x to the 4th plus 15x cubed equals 90x squared. Again, the first thing that I want to do is write my equation in standard form. So I'm going to subtract 90x squared from both sides. So I have 5x to the 4th plus 15x cubed minus 90x squared is equal to 0. Okay, I notice here that there's a greatest common factor of 5x squared, so I'm going to factor that out first, and then see if I could do any further factoring. Okay, once I factor out the greatest common factor, I'm left with this quadratic trinomial. Let's see if it factors. So I have x squared plus 3x minus 18. So are there 2 numbers that multiply to negative 18 and add to 3? And there are. 6 and negative 3 will factor this. Okay, in this polynomial, I have 3 different factors. So I'm going to set each of these 3 equal to 0. So I have 5x squared equals 0, x plus 6 equals 0, and x minus 3 equals 0. Okay, solving 5x squared equals 0, I would divide each side by 5 first. X squared equals 0, so x has to equal 0. Next equation, x equals negative 6. Last, x is equal to 3. Okay, so here I have 3 different solutions for this polynomial. Remember what the degree of a polynomial tells us. It tells us the number of possible solutions. So in the first example, I had a quadratic polynomial, so I had a degree of 2. So that means I could have a maximum of 2 solutions. If you had solved this and gotten 3 solutions, that would have been wrong. You can only have as large as the degree of the polynomial. For this middle example here, my degree is 4. So that means the maximum number of solutions I can have is 4. And I got 3 solutions. So that means that I'm within the degree of the polynomial. Okay, last example, I have x squared plus 5 plus 1 equals 0. So this is already in standard form, so that's good for us. That's done. So now let's factor this polynomial. It's a quadratic trinomial, so we're going to see if the AC method will work. So I'm looking for 2 numbers to multiply to 1 and add to 5. Well, that doesn't work. This polynomial is prime. So that means there's no solution. Okay, next example. We have 3x squared is equal to 2x minus 5. I like to always keep my leading coefficient positive because that way I don't have to factor out a negative number later on. So I'm going to subtract 2x minus 5 on both sides. So I have 3x squared minus 2x minus 5 is equal to 0. Okay, this is a quadratic trinomial. The leading coefficient is not 1, so I'm going to use factor by grouping. So what 2 numbers are going to multiply to a negative 15 and add to a negative 2? Negative 5 and positive 3 will do that. So I have 3x squared minus 5x plus 3x minus 5 equals 0. Okay, and I'm going to factor this by grouping. So x times 3x minus 5 plus 1 times 3x minus 5. So this factors into 3x minus 5 times x plus 1 equals 0. Let's set our factors equal to 0 and use that 0 product rule. So x is equal to 5/3 and x is equal to negative 1. Okay, 25x squared plus 70x plus 49 equals 0. We're already in standard form, so that's great. I notice here that I have a perfect square trinomial by looking at these first and the last term of my polynomial. So I'm going to factor it using my rule. This is going to be 5x plus 7 squared is equal to 0. So instead of solving by setting both of my factors, 5x plus 7 and 5x plus 7 equal to 0, I only really need to do this once. So x is equal to negative 7 over 5. Last example. So I have x squared is equal to 9. So I'm going to subtract 9 on both sides. X squared minus 9 is equal to 0. That's a difference of squares. So x plus 3, x minus 3 is equal to 0. X plus 3 equals 0. X minus 3 equals 0. So x is equal to negative 3 and x is equal to positive 3. So I know what some of you are thinking. Some of you are probably thinking, why can't I just do this? Why can't I just take the square root of both sides? Okay, the reason why is if you take the square root with just the knowledge that we have so far, we're going to have x is equal to 3. And that's only one of the solutions, and there's 2 solutions to this equation. So I want you to resist that urge to take the square root of both sides. We will eventually solve polynomial equations using the square root property. But the key here is that the square root of x squared is not equal to x. It's actually equal to the square root of x, which we're going to talk about in another lesson. So for now, let's just stick to solving by factoring.